Lab 30-1. Today we are going to learn how to evaluate logarithms, okay? So let's just start here. There's a little opening exercise, but I'm going to start right here with class example number 1. We want to evaluate the following logarithms. So I'm going to first convert this to exponential form. So this is going to say 3 to the power of x is equal to 81. So now I'm going to solve for that x there. I can make this change a base and make it the same thing. So I have 3 to the x is equal to, this is 3 to the 4. So then x is equal to 4. That is it. Let's take a look at the next one. This is saying 4 to the power of something is equal to 64. Okay? Now, if I go like this, this is 4 to the power of x is equal to 4 to the power of 3. So 8, 16, yep. Now I get x for this one is equal to 3. Okay, let's take a look at the next one. We have 7 to the power of x is equal to 7. Well, this is 1, so x is equal to 1. That one was very simple. And now the last one. So it looks like an identity to me, so I have 12 to the power of x is equal to 1. Well, what is that magical number x? Well, anything that makes 1 is 0, so x is equal to 0. It's another identity. That one is very simple as well. So that's not that bad if we know our exponents and we know how to square root fast and know our multiplication tables. Now, here's a little interesting one. We have b to the power of y is equal to 1. So b to the power of y is equal to 1. Well, every single time we get this, if we have this here, this is equal to 0. So anytime we have something like this, if I have log base b 1, that's always going to be equal to 0. It's a good thing to kind of look at. So always log base b, or any number, when it's 1, this is always equal to 0. So even if that's 1,000, 500, 800 million, anything like that, it's always going to be equal to 0. Okay? Let's try to look at another one. Next one. Now, well, this is the same thing as b to the power of x is equal to b. Well, here, x is equal to 1. So that's another neat identity. So log b to the b is always equal to 1. So if b is 5 million, then this must be 5 million, then it's going to be 1. Doesn't matter. If these two numbers are the same, it's always going to be 1, the value. Okay, that's a nice little identity to know. It can help us solve some really interesting problems later on, especially when we get to the next unit. All right, here we go. Let's evaluate now this one here. So, first of all, what must we do? I have to put this in base 8 and find my exponent. Okay, so I'm going to have log. I'm going to make it equal to something. I want to have an x there. Log 8, 512 is equal to x. I'm going to divide that by 2. Okay, so now I have my log by itself. It's easier. Okay, now we got to put into terms of exponents. All right, so we're going to go 8 to the x over 2 is equal to 512. All right, now, that's interesting. So what is this here equal to? This is going to be the same as multiply, this is 8 to the 3 is equal to 8 to the x over 2. All right? Now, we try and solve this more. I get x over 2 is equal to 3. So x is equal to 6. Okay? There we go. Because 512 is the same as 8 to the power of 3. Let's take a look at the next one here. We're going to have, 2 to the power of something, 2 to the power of x. I'm going to make this equal to x. 2 to the power of x is equal to 1 over 32. So I'm going to make this here the same. So I'm going to say 32 to the negative 1 is equal to 2 to the x. Now this is the same as 2 to the 5. So we have 2 to the 5, then negative 1 is equal to 2 to the x. So then I look at this, this is power over power, x is equal to negative 5. Okay? Let's try this next one here. A little bit more complicated. We're going to have 5 to the power of something, I'm going to make this x, to the power of x or something is equal to the square root of 125. Alright? So that's like saying 5 to the power of x is the same thing as 125 to the 1 over 2. Fractions make it look better in this case. Now I can break that down to a same base of 5 is equal to 5 to the 3 all to the 1 over 2. Oops, this is an x. So I end up getting x is equal to 3 over 2. And that's it. Okay? So my final answer here is 2 log 512 is equal to 6. Here we get log base 2, oh, this is in base 8, base 2, 1 over 32 is equal to negative 5. And here I get log of base 5, square root of 125, is equal to 3 over 2. Okay? So that's how we solve those. So every time we just isolate for x. Now here's an interesting one. It says log power of 5 to the power of log 5 to the 5. Well, first, let's look at my log. To the 25. What does this equal to? Well, this is equal to x. So that's like saying 5 to the x is equal to 25. So x is equal to 2. So now I can put all of this back in for my power. So it's 5 squared is equal to 25. So that is my answer. So I know log, make this a bit bigger here. So I have 5 to the power of log 5 to the 25 is equal to 25. That's it. Okay, let's try to look at this next one. Alright, so we have 749. It's kind of following the same example. So I know log, I'm just going to look at my exponent first, because I could solve for this, that's a number. Log 7 base 7, 49 is equal to 2. I know that automatically, because it's saying 7 to the power of what is equal to 49? It's 2. So I have 7 to the power of 2 is equal to 49. So basically 7 log 40 log 7, 49 is equal to 49. Huh, interesting. So let's take a look at this next one. We have 3. Let's first look at my log. Log base 3 to 27 is the same thing as 3, because 3 to the power of 3 is equal to 27. Okay? Now, let's try to solve this out. I'm going to end up getting, we have 3. 3 to the power of 3 is equal to 27. So 3 log 3, 27 is equal to 3. So what did we notice here? If I notice, all of these bases are the same as my base there. Okay? So when I have a to the power of, and I have log, and my base of log is that, my answer is always going to be n. Okay? It's always that n value. So determine log a to the n. Well, how do I do that one? Let's try this out here. We want log a to the n is equal to x. Okay? Well, now this is saying then a to the x is equal to, right, this to the power of that is equal to a to the n. Oh, so my answer is always going to be n. Log a, x is equal to n. A to the n is always equal to n. Whoops, sorry, we couldn't see that. I'll try and go over this again. So, when we're looking at this here, I did log a to the n is always equal to x, right? So a to the power of x, right? This to the power of x is equal to that, right? This to the power of that is equal to that. So then I had x is always equal to n, all right? Now, so this here is equal to, this here is equal to n. So every time I have log base a to the power of n, it's always going to be equal to n, to that exponent. And that's it. Does that make sense? All right, here we go. Now, we're going to look at common logarithms, and we're going to need our calculator for this one. So here's something we have to follow. A common logarithm is when the base is 10. So log 10 to that is the same thing as saying log 1,000, okay? So anytime they don't put a base, we assume 10. That's normally what it means, okay? It's like not writing a 1 in front of a. If I just say x plus 5, I'm assuming it's 1x. There's a 1 there, right? Just like in the logs, there's this imaginary 10 there, unless stated otherwise. When we put square root, right, if I say square root of x, well, there's an imaginary 2 here. We just don't write it in. Unless stated otherwise, we assume it's a 2. Same thing with logs. Unless stated otherwise, it's going to be a 10 there. All right? Now in our calculator, our log button right over here, if we see it, it's right there. That's our log button. That is always in base 10. It's our common log. So here we go, evaluate the following by converting to exponential form. So we have log base 10 is equal to x. So that's 10 to the x is equal to. So here we get x is equal to 3. So this is the same thing as 10 to the 3. Now let's try it in my calculator. Okay? So I'm going to just move out a bit so we can see it. So I'm going to put it on, and I want log. I hit my log button. Okay? And I want 10,000. So I punch in 10,000, or 1,000. 10,000. I close my brackets, so it looks like that. And I hit enter, and I get 3. Exact same answer. Okay? Next one here says, in each of the following, estimate the value to the nearest whole number without using technology and explain the reasoning. Okay, then number 2, approximate the value to the nearest hundredth using technology. Okay, so the first one, let's take a look at this. We want 10 to the power of x is equal to 89. Okay, so I look at that, 10 to the power of x is equal to 89, and I know 10 to the 2 is equal to 100, and I know 10 to the 1 is equal to 10. So I'm going to say it's closer to 2. So I'm going to say maybe 1.8, 1.9. So it says estimate the value to the nearest whole number. I'm going to say this is approximately 2. Okay, so for I want to say it's approximately 2. But let's use my calculator to find out. Okay, let's try this out here. We just push in log, then I'm going to put 89, so it looks like that. Hit enter, and I get 1.95. That's my answer. Okay, let's take a look at the second one. We want log 2,000. So that's saying 10 to the x is equal to 2,000, right? Now, I know 10 to the 3 is equal to 1,000. Now this is double that. 10 to the 4 is equal to, so this is closer to 3. So I'm going to say this is equal, for number 1, it's equal to 3. Now let's try it in my calculator. So we're going to punch in log 2,000. Okay, so it looks like that. Oops, that's 200, 2,000. Oh, I did natural log. We want log 2,000. Sorry, wrong button. So I get 3.3, and that looks about right. 3.30. Okay? So I would have guessed maybe 3.2. Here I would have guessed 1.7 and 1.8. So I still would have been off. But it's neat to have that graph in calculator. Alright? Now, there's one more thing we have to do here, and that's the natural log key. That was the key I pushed before. Now, natural log is always when my base is e. We use natural log when it's base e. So if I do this, this is the same thing as that. So evaluate the following to one decimal place where necessary. So this is the same thing. I'm going to write this as saying log base e to the 5. Okay? Or e to the x is equal to 5. And e is a number in your calculator. Okay? It's a specific number. But let's try this out here. We're going to have this, so we're just going to push ln5, enter. I end up getting 1.6. Next one here, we want log e to the 5. Well, that's going to be the exact same thing. That's the same thing as saying. Okay? And ln e. Well, what is the natural log of that? Let's try that. and I want I get 1, okay? So this is 1, and that makes sense. That's like saying log x to the x, right? Because this is saying log e to the e. So that's going to give me 1. E to the power of what is equal to e? 1. There's my answer. So these last few questions, we're going to look at something like, well, how do I plug it into my calculator when I have that 5 there? How does that work? How do I go log 5 to the 25? Right? Log base 5, 25. Well, there has to be a way. And I'm going to show you how. We're going to use this change of base formula right here. Later on in this class, we'll figure out why this formula works and how they made this formula. But right now, I'm just going to show you how to use your calculator. So let's check this one here. This is going to be the same as log, using this formula here, log 221 all over log 5. That's what we put in our calculator. So let's try that out. We have log 221, okay, and then we have bracket, enter, then we're going to divide that by log 5. And I get 3.35. Okay, the next one here is base 2. So we want log 1 over 1,000 divided by log 2. So let's try that out. Okay, so we want log 1 divided by 1,000. And then we want to divide that by log 2, because we always do the base on the bottom and the main number on top. And I get negative 9.96. Oh, 97. Now the last one, we have this 3, which makes it a little bit more difficult. But it's not that bad. We're just going to multiply that answer by 3, because it's 3 multiplied by whatever that answer is. So I'm going to have log, once again we're going to log, we go 5, what was it? 512. And then we are going to divide that by log 7. Okay, so we get that. So we have 3 now multiplied by 3.21. Then we have to multiply that by 3. And I end up getting 9.62 is my answer. Okay, and that's it. So that's how we do the change of base for those. Okay, so here we want to convert the following logarithms to the base indicated. So this here to base 3. Well, before we were converting to base 10, so essentially that's the same thing as converting to base 3. So that's going to be log base 3, and we'll have 216 all over log, and we're in base 3, 6. Okay? Just change it to base 3. That's it. It'll essentially give us the same answer, but it's in base 3. Now let's take a look at this one. We want this in base 5. So it's going to be log in base 5. We have 3,000. Remember, or 300, remember there's imaginary 10 there. We have log, base 5, 10. That is it. Okay? Now the next one says, find the exact value of the following. Alright, so we're in base 10, so I'm going to have to go log 1 over 343 divided by log 7. These are in base 10, and then I have to multiply that by all by negative 1. Okay? So let's try that. We have log 1 over, move that down a bit, 1 divided by 343, bracket, and we want to, 343, and I push enter, and then we times that by negative 1, and that's going to give me 2.53. Shouldn't be it, that should be 3, I made a mistake there. And we have to divide that by log 7. That's why. 3, which is equal to 3, because 7 to the power of 3 is 343. So this one right here, let's look at this. So we might even be able to solve these. You could solve these in your head, because 6 to the power of 3 is 216. Now, then that's going to be 216, so this to that. But let's double check using the calculator. So we're going to have log, so this is 6 to the we want log 216 all over log 6, right? And we know this should be equal to this from our identity earlier, but let's check if it's right. See if we're doing it right. Because we might make a mistake like I did last time on the calculator. So we're going to have log 216 bracket divided by log 6 bracket, enter, and I'm going to get 3. So that is 6 to the 3, and we have 6 to the power of 3 is 216. Hey, that's exactly what we said it was going to be. So that's how we do that one. This one here may look a little bit more different. So we go log square root of 1 over 1024, and then here we're going to go all over log 2. So let's plug that in. Log, we have second square root, 1024, and, oh, then it's 1 over. We're going to close the bracket, enter, and we're going to divide that by log 2. So I get negative 5. And the last one is 7 to 49. So this is going to be, this should be equal to negative 10. Let's double check. Alright, because 7 squared then to the power 2 is 10. So we go log 49, bracket, enter, divided by log, let's see, log 7. Then we want that to the, oops, sorry, I made a mistake here. So we have log 49 to the power of negative 5. Hold on. Log 49. Here, let's go 49 to the power of negative 5. Enter. And we're going to log that. Log. I get that. And then we want divided by log. Where's this? Log 7. I get negative 10. Exactly what we got there. Okay? See how I did that? Well, hopefully you understand this. Good luck as I see you tomorrow.